So now we will take a look at the several examples of how can we build a process flow chart by using a diagram. And here we will talk about a different kind of a processes, starting from the linear process. Then we'll get down to the branching process with the conditional statements. And of course, we will touch the questions of a cyclic process where we repeat one or another operation several times. So let's take a look to the monitor. When we are going to design the process, we need to identify the starting point. So I will use here an ellipsis. It will be our starting point of our application. So now we would like to identify the second step of our algorithm. For example, we are designing a program that's saying to us, "Hello world." The very simple and the first program that every programmer writes down all around the world. So making an output to a user saying a hello world is an action and also as an output of a program that is designed. So we can use here a rectangular form so that it will be a parallelogram that identifies an output of our program. And to write down this shape, I will use just lines. Now, within this parallelogram, I will write down a specific action I would like to user receive as an output of a program. So I will say here, "Hello world." And after outputting the result, we are going to finish our program. So here's a very simple representation of an algorithm within a flow chart. Now we will improve the logic that we are going to execute here and make our program more complicated so that we are expecting from a user to input his name, and then we will greet him personally. And to express this operation as a flowchart, I will insert several repeating elements like parallelogram that expects an element from a user to be inserted. And we will write down here that a variable as a name is expected to be inserted by a user. Then we need to be this name concatenated to the word hello, so that we need to use an action here. And an action is expressed as a rectangular form where we identify the operation of concatenation of name, the variable of greeting, plus, let's say it will be a space and plus name. So the greeting now is equal, the output is equal to a greeting plus name and the initial greeting word. And we will output the resulting string here. I will make it smaller to put a necessary number of arrows that are going down through the execution of application. Now we see that when our application starts, it expects a variable name to be initiated by a user. Then this value is assigned to an initial string as a greeting that has its value as hello. And the combination of these strings are printed out as the final result of this application. Thus, this is the primary way how can we express a linear process within an application. Now we are going to express the conditional statement and make the flow of a process or an algorithm to go two different ways. And we will imagine this situation as a person that puts down his age, for example, and according to his age, we will determine should we pay him money as a salary or should we pay him some pensions if he is old enough. So now we are expecting an age from a person, and if he inserts his age here, we need to check if this age is appropriate to a predefined condition. Let's say that it will be less or more than 50. So here we need a special kind of a figure as a diamond to represent a condition. Let's put a diamond here. I don't have actually diamond. Oh yes, I have one. And within this diamond, we will say that if age is greater than 50, and if this is true, we will make a flow of our process to go a different way, like saying output the result or output an absolutely different result according to the age value. So here we will say, for example, if he is greater than 50, then we will output like you are a middle-aged human. Or if it is less than 50, you are young person. And both of them can go to output a result. Now we need to express a flow to the final state of our algorithm. Well, take a careful look to this expression of a flow so that depending on the input value of a person or a final user, the algorithm can go one or another direction of instruction execution. And then it will output the necessary value that is expected according to the pre-designed algorithm.